Hello, and welcome to Summarize Science. When we think of language, we often think of spoken words, but language is so much more than that. Signed languages, for example, are rich, complete languages with their own grammar and structure. A fascinating aspect of many signs is iconicity, which is the resemblance between the form of a sign and its meaning. For instance, the sign for telephone often mimics holding a phone to your ear, making it visually intuitive. But the sign for sugar might not have any obvious visual connection to sweetness at all. This raises a huge question for the world of artificial intelligence. Can advanced AI models, which are getting so good at understanding images and text, actually understand the visual meaning in sign language? Researchers decided to put this to the test by creating the Visual Iconicity Challenge. They tested 13 state-of-the-art vision language models, including powerful ones like GPT-5 and Gemini 2.5 Pro. The AI was given three main tasks to see how deeply it could understand signs from the sign language of the Netherlands. First, could the AI break down the basic components of a sign, like its hand shape, location on the body, and movement path? The results showed that the AIs were decent at spotting simpler things, like where a sign was happening or if it used one hand or two. But they really struggled to identify the specific hand shape or the shape of the movement, something humans find much easier. The second task was a transparency test, basically a game of visual charades. Could the AI guess a sign's meaning just by watching a video of it, with no other clues? Here, the AIs performed very poorly, falling far short of human performance. Even the best model only guessed 17 out of 96 signs correctly in the most difficult version of the test. The third task was to see if the AI could rate how iconic a sign is on a scale from 1 to 7, just like humans can. While the top models showed a moderate ability to do this, a really interesting bias emerged. Humans are typically better at understanding signs that depict an action, like brushing teeth. But the AI models showed the opposite pattern. They were better with signs that represent a static object's shape, like the wings of a butterfly. This suggests that current AIs are more like static image recognizers than dynamic action interpreters. They're good at seeing a shape that looks like a thing, but they struggle to understand the meaning behind a human movement. So, let's recap the important points. While today's powerful AIs can pick up on some basic visual elements of sign language, they are still a long way from truly grounding meaning in human motion. They struggle to identify detailed hand shapes and movements, and they are very poor at inferring a sign's meaning from its form alone. Most tellingly, their bias towards static objects over dynamic actions reveals a fundamental gap in their understanding compared to humans. What does this mean for the future? It shows that to build AI that can genuinely understand and interact with humans, we need to move beyond simple image recognition. Future systems will need to be trained specifically on dynamic human gestures and the underlying principles of embodied communication. Truly understanding sign language isn't just about seeing a hand, it's about understanding the action, the intent, and the story it tells. Thanks for watching Summarize Science.